This is IAQ Radio, Indoor Air Quality Radio, the voice of the indoor air quality industry, with your hosts, Radio Joe Hughes and the Z-Man, Cliff Zlotnick. And now, Radio Joe Hughes.
Good day and welcome to IAQ Radio Plus, episode 679. This week we welcome Dr. Serene Al-Momen, CEO of Senseware, and we're going to talk about sensors, IAQ, and IoT, putting the pieces together. Before we get started, let's thank our sponsors. They're the reason we can continue doing the show. And don't forget, after the show, we have the afterthoughts.iaqradio.com, where you can continue the discussion, sponsored by First On Site. Our marquee sponsor is First On Site at firstonsite.com. Our association sponsors are the American Conference of Governmental Industrial Hygienists, ACGIH.org, the American Industrial Hygiene Association, AIHA.org, the Cleaning Industry Research Institute, CIRI Science.org, the Institute for Inspection, Cleaning, and Restoration Certification, IICRC.org. Industry sponsors are AEML Laboratories, AEMLINC.com, Particles Plus, ParticlesPlus.com, TSI Inc., TSI.com, Sunbelt Rentals, SunbeltRentals.com, April Air, April, AIRE.com, Healthy Indoors Magazine, HealthyIndoors.com.
And now you can win a cool prize. It's time for the IAQ Radio Trivia question. Be the first to correctly answer. Simply email your answer to czlotnick@cs.com. Or if listening live, just text your answer from your computer. And now, here's the Z-Man.
All right, the Z-Man's away today, so I will take the trivia question. The IAQ Radio Trivia question for October 28, 2022 is sponsored by TSI Inc., an industry leader in precision instrumentation for monitoring indoor air. Learn how to expand your IAQ investigations at tsi.com. Here's the question. How many connected IoT devices are estimated to be in existence today? All right, so today we've got Dr. Serene Al-Momen. She has built Senseware from the ground up. She found a niche group of building owners, engineers, general contractors, and energy consultants that were at a disadvantage by not having wireless instant access to real-time facility and site data. As the co-founder and CEO of a high-growth technology company, she worked to provide a modern IoT-enabled technological solution to an age-old issue in an industry that was previously ignored by the IoT sector, the commercial and industrial real estate industry. Welcome to IAQ Radio, Dr. Al-Momen.
Thank you for having me. So excited to be here.
It's great to have you. I've had a great time chatting with you during the week to kind of get ready for today. As a lot of our listeners know, this is kind of like putting it all together. We had, Subu Submaranian on. We talked about sensors, and then we had Marwa Zatari, Christian Weeks, and Eric Malmstrom. They were, involved in this same kind of platforms. And then we had Mark Ames at the White House Summit on IAQ, and they had the guy on from Denver Public Schools, and when I started talking to you, I didn't realize then he's using your product. So, congratulations! This is a great way to kind of tie it all together.
Absolutely.
But anyway, I want to welcome you, and let's talk a little bit how you got started in this industry. I gave kind of the background. How did this issue first come to your attention?
Yeah, it's a good question. It's an interesting story. So by background, I'm a software engineer. So I started right out of college, just cranking code, debugging software applications, especially for the government as a government contractor and things like that. And I continued my graduate degree and moved into focusing on healthcare IT. During just the last kind of stretch of finishing out my PhD degree, I met my current partner in a conference in Portugal that was related to healthcare. And he was talking about some of his invention and research work. And I always wanted to start my own business and entrepreneurial by DNA, I would say, came from that family kind of experience as well and background, and always scanning for the light bulb moment where I hear something that I feel like, oh, I can take this and make something out of it. And that happened to me in that at that conference when I met my current partner. He was talking about his work in Parkinson's disease research, and it revolved around using sensor technology to better to improve that whole process for physicians, and using sensor data and connecting the physical world to the digital world. And it's just all of these factors, and given my background and passion to do something significant, the idea behind Senseware came about. So that's how it all started.
And are you still working in the healthcare sector at all, or did you put all the focus now on this indoor air quality segment?
We started wanting to target that market. So we took that invention that Julian, our current CTO, my partner, put together, which used accelerometers as a sensor technology to better assess Parkinson's disease patients. And one of the things that we started with is, as part of that research, there were two areas of improvement. One was related to adding other types of sensors, not just accelerometers, because with those types of patients, the tremors have movement sideways, not just issues with acceleration. So a sensor like gyroscope would be great to add to the mix. So just having multi-sensor technology was an area of improvement that we wanted to develop. And the other piece of it is that the sensor technology at that time was in early stages, and we knew that they will continuously improve into the future. So we wanted to also create a technology that you were able to exchange even the same type of sensor with the new advanced versions of those sensors into the future. And so we did that. That's really what we created, a multi-sensor technology that is able to add new sensors on the fly and also exchange existing sensors with new and improved sensors. And we wanted to target the healthcare industry with that, given the background. But we did find interest mostly from the built environment and buildings and building operators that came to us and said, well, if you're able to connect to any sensor and change the sensors and the data that you're collecting in real time, can you do the same thing for our buildings? And that took us into this market where we found the most success and interest in this type of technology. So that's what we're focused on right now. But if you look at it, instead of just getting real-time data and status from patients, we're doing kind of the same thing, but for buildings. We're monitoring the health and the status and the state of the buildings in real time in kind of the same way, but just different type of application.
I see you've got this detail up here. What are we looking at now?
You mentioned Denver Public School, and listening to the superintendent in the White House Indoor Air Quality Summit that happened a few weeks ago. This is just a quick snapshot of what the dashboard looks like at one of the schools in Denver with the real-time data overlaid on top of this. So all the green dots are where the IAQ sensors are deployed, and the color changes based on the thresholds that are set up. And we've worked in collaboration with Dr. Mark Hernandez and the school environmental services team headed by Joni Ricks, who came up with the right thresholds for the types of schools or the types of building and the systems in schools. So this would change to yellow and green based on all of those factors. The people on site and anyone that needs to know that something exceeded the threshold will get an email and a text alert. So this is the way of continuously around the clock, 24/7, keeping that environment, the school building and classrooms at a healthy, acceptable level.
Are there also red dots? Is it green, yellow, red, or just green and yellow?
Green, yellow, red, for sure.
Okay.
And we've seen reds in places where we didn't expect, which is the power of sensors, where you're able to see the unseen. And sometimes you're feeling comfortable in a place, you're not, there's no odor or stuffiness or whatnot, but that doesn't mean everything is fine. And we've had many situations where this is red and it's surprising and it's a real issue that just no one knew, and sensors could pick up on them.
All right, one of our audience, Ralph, read my mind here. What parameters are they monitoring here? Is this particulate, CO, CO2?
Yes, and the standard would include temperature, humidity, particulate matter, sensors, CO2 levels, and VOC. And you see some of those here, in this other
Interesting
view. And that's kind of the typical one. And then what we also do, you see a small widget up there that is named VPI after the PM, and that's called that stands for the Ventilation Performance Index. And the idea behind this particular data point, this is not coming from a sensor. It's using the sensor data to create an calculated metrics around ventilation performance. So it's taking contaminant levels like CO2, VOC, and particulate matter, and looking at the rate of decay over time. And that would tell you, okay, even if there are elevated levels in these contaminants in the space, if they're removed at a good rate, then there's nothing to be worried about. And which we feel is another layer to just looking at sensor data, is using analytics to have more consultative action-based changes.
And now, how often are these sensors calibrated?
Yes, that's a good question. The way we approach it is that we pick sensors that either auto-calibrate or have low drifts. And the reasons we do that is that practically it's really hard, especially at large scale implementation. We're looking at schools that are going to deploy in every classroom. It could be 10,000s of units to calibrate. So we look at accuracy of sensor and also the sensors that can auto-calibrate. So you don't have to maintain the sensors or replace them on a regular basis, which could be prohibitive. So that's the approach we're using with our sensors.
Now, are these off-the-shelf sensors, or are these things that you've built to work with your system?
So they are third-party sensors that we use and procure from the sensor manufacturers, and we integrate them with our own solution around indoor air quality monitoring. So we take those different sensors, we place them in our own hardware that we design, that is a wireless-based type system. So we take care of also that piece, creating a wireless network in the space where they're deployed. And then we also developed the cloud dashboard that you're seeing right now. That's all our solution, but the actual sensors come from the sensor manufacturers.
So when something is off and it's in the red zone, does someone automatically get an alert, or is it, how does that work?
Yes, so we create teams that need to know. So there are teams that are people within the building or the organization that don't necessarily need to get alerts, but the team that need to get the alert so that they know and can address the issue, get real-time alerts via email or text so that they know as the issues are happening and are able to make the changes in near real time to keep things at a good level around the clock.
Now, you were kind of coming in with somewhat of an outsider's perspective on the whole IAQ issue. I'm wondering, what was your first impression when you started looking at how buildings and schools and people in general are evaluating their indoor air quality?
Yeah, it was very insightful as we got more into understanding the different types of buildings. The main thing that we have we've learned very quickly is that there is a big issue around knowing what's happening in real time in these environments. So that the lack of visibility around very important aspect of buildings was, the big kind of eye opener for us. And so that was one thing, and a lot of those organizations and operators of buildings kind of started with an intervention. So when they were thinking about, okay, we need to operate the building to be also healthy, they started thinking, oh, we need to install HEPA filters and change filtration, all that stuff, which is amazing. But what had happened as they did that is that the confidence was still not increasing in people wanting to go back or feeling comfortable going back in indoor spaces, especially in schools. And the reason behind that is that they didn't have the data to show that things are working as they should. And also the data that shows that if something goes wrong and these measures are not working as they should, that they'll know and they'll do something about it in real time. So that's something that we also noticed, learned. And it's summarized by, the fact that you cannot manage what you don't measure, and that's largely missing, a big issue in commercial and buildings and schools.
And I've got a text question here. It says, no drift. Are you using the sensor manufacturer's claims, or are you testing that performance yourself?
Oh, we do test the performance ourselves, but the first step for us is that when we pick sensors to use, just coming from the healthcare background, we do not compromise on the quality of sensors, period. And because of that, we perform a lot of diligence in picking the sensor manufacturers that we work with. And the big criteria for us is that we go to the sensor manufacturer that is the original inventor of that sensor technology. And we procure directly from the innovators of those sensor technologies. And that cuts a lot on, potential of using sensor that's not good. But once we do that, and we actually procure the best sensors, best in class, we definitely do a lot of testing ourselves internally in our R&D labs and make sure that things are as they are, the manufacturers are claiming, and before putting them into the market, integrating them into our product.
Interesting. And since you're probably, well, let's start with this. How do you choose where to put the sensors once you've got a client like the Denver Public Schools? What do you do to figure out, okay, what's the most important place to put these sensors?
Yes, it's a combination of our own experience, some looking at some guidelines, like what well and fit well type organizations are putting there, and talking to the actual client, the school officials and facilities team, commercial real estate engineering team, and bringing all of that together to figure out location. So sometimes, for example, for some commercial real estate buildings, building owners and operators, what they want to get access to in real time when it comes to air quality is what they call core and shell of the building. And so they're focused primarily on how their HVAC systems are operating. So the ventilation system and the configuration they did to enhance air quality, and the filtration improvement that they did, whether they went to MERV 13, 15, what have you. And so in those cases, based on that input, that's the data that they want. They want to know if these new changes are working properly. We focus on core and shell. So we're putting the sensors in the outside air, supply air, and return air ducts, and looking at the data continuously in those areas. Then you have schools, for example, that are in states that mandate indoor air quality monitoring in every classroom, or at least CO2 levels. And so for those types of buildings, school buildings, we have to put a monitor in every classroom. And so it really changes based on the circumstances, who we're working with, and what are they trying to do with the data.
I've got a couple other follow-ups from our audience, but first, you said some states mandate this type of monitoring. I wasn't aware of that. Can you tell me more about that?
Yes. So the first one that I'm aware of, because I was involved in that process, is California. They had a bill that passed by Governor Newsom in late 2020 that is requiring schools in California to monitor CO2 levels at the minimum in every classrooms. And that was at the heels of understanding that school buildings have aging infrastructure when it comes to HVAC, and how it's important that we improve air quality in this learning environment, especially CO2 levels, because it's tied to cognitive health. And there are effects on energy consumption and conservation when you're monitoring CO2 as well. So all those together created this bill that was passed a couple of years ago. And so the schools in California are looking at ways to comply with those mandates. Recently, Maryland State also passed a bill that requires schools to report twice a year on the CO2 levels in all their classrooms. And so that initiated few efforts in some of the districts in Maryland to start to look at technologies to do that. And these are just a couple of states that I'm aware of, but we believe that more states will come on board. I hear that Nevada is also looking at doing something similar and whatnot. So I think it's coming to all states. All
right. Well, I got an audience question here. What is the sensitivity of your particle sensors at, for instance, 0.1 micrometer?
I don't have that handy, but we can send that after if needed.
Okay, if you send that to me, we'll put it in the blog.
Yes, sure.
Now, the other thing I noticed that your group seems to focus on is energy. Right. You're not just looking at indoor air quality; you're tying in energy. Now, I didn't notice on the dashboard that we looked at where the energy was that shown on that, and I missed it.
No, it's that particular dashboard was geared towards indoor air quality monitoring type data. But yes, the energy side is a big factor in managing buildings nowadays, because buildings, there are three, when you're operating a building, there are three factors, or the three-legged stools are comfort, which is levels of temperature, humidity, too hot, too cold. So keeping an eye on that. Energy, that ties to operating expenses in the building. And then now HVAC type data for the health and wellness of that type of indoor spaces. So you have to look at all these three data points to make sure that you're managing, being responsible for the buildings and the people that are occupying those spaces. And so what has happened in the past is that there was this interest in energy conservation. So there is some data around energy in the market. They are leading the pack in terms of data that is available in buildings. And then when COVID hit, there was a push to add the indoor air quality type data, which is largely missing from all types of indoor spaces. And temperature humidity is typically there with the thermostat and whatnot. So these three data points are always important, and will continue to be important to optimize, to look at together, to make sure that buildings are performing well, they're staying healthy for people, and that we know that there is a lot of sustainability targets with ESG, decarbonization activities and push, and so all of those things are now becoming really important.
All right, so what we're going to do, we're going to take a little break for what we call our halftime here. We're going to thank our sponsors, and I'm going to try and get back on the main line, but we'll see how that goes. I'm going to keep the phone line open just in case. So we'll be back with our guest, Serene Al-Momen. We're looking forward to the second half of the show. Our marquee sponsor is First On Site, your trusted full-service disaster recovery and property restoration company at firstonsite.com. Association sponsors are ACGIH, Advancing Careers of Professionals in Environmental Health, Industrial Hygiene, and Safety, interested in defining their science. ACGIH.org. AIHA, Healthy Workplaces, A Healthier World. AIHA.org. The Cleaning Industry Research Institute. See more deeply through science and research. CIRI science.org. The IICRC, a nonprofit standards development and certifying body for the cleaning and restoration industry, IICRC.org. Industry sponsors are AEML Laboratories, free shipping, great pricing, same-day results with no rush fee, AEMLinc.com. Particles Plus, feature-rich particle counters and air quality instrumentation. Count on us, particlesplus.com. TSI Inc., an industry leader in precision instrumentation for monitoring indoor air. Learn how to expand your IAQ investigations, tsi.com. Sunbelt Rentals, availability, reliability, and ease for all your IAQ and restoration needs at sunbeltrentals.com. April Air, healthy home, April, AIRE.com. And Healthy Indoors Magazine, a free online magazine for industry professionals and consumers, healthyindoors.com. So, integrating the data you collect with building management systems, that's kind of the holy grail. So getting your data, your sensors connected to, and I'm not an expert on this, so correct me where I'm wrong, they're connected to your system, which is then connected up to the cloud, and then they get their data back. And now we're trying to coordinate that with our building management systems. How is that going? Is it going to be tough?
Yeah. It is, like you said, the holy grail, and it's where the industry is moving, especially now with the increased interest in indoor air quality. But before I go too much into the building management systems and integrating with them, I was reading market research the other day, and it was saying something like 80% of buildings don't even have building management system. And that makes
80%?
Of buildings don't have building management systems.
Okay.
They're just too small. They just, don't need that sophisticated type platform and technology in place. And that makes the need for IoT solutions, which are retrofittable sensor-based technologies that can get the data that typically BMS gets. There is energy, airflow, and now indoor air quality into more of a virtual type BMS. So there's an application for that. But there's also the buildings that do have BMS. And yes, your question about integration with those is important. And there are two things that we do in terms of integrating with the BMS for different purposes. The first is integrating with BMS to get the data out of the BMS to make it more real time from anywhere at any time, and tie that to the other data set that we augment with our sensor technology. So in this cloud platform that you're seeing, we can start to now also add the BMS data. So the BMS in that case is just like another data source that we connect to with our hardware, our IoT technology and system to grab that data. And now it becomes real time, more meaningful, change the whole operation of the building to be more proactive versus reactive. And so that's one type of integration, is bringing it to the data, taking it from the BMS on site to the cloud, adding other data points, doing powerful analytics and proactive, changing to proactive integration, operation of buildings. The other piece is what you're saying is that if you have a BMS, you adding new data points that the BMS didn't have before, as far as how it's operating HVAC systems and whatnot. And now we're adding those data points around health and wellness, which is IAQ type data that's missing, that the BMS didn't have before, as you know, when you're changing set points and doing the rules, you know, about how the BMS is configured. And now we're able to also integrate that into the BMS so that it takes those additional particulate matter level, VOC levels into consideration, CO2 levels, versus just temperature and humidity, which was the past, you know, how it used to work.
Maybe CO2.
Yeah, CO2 is a big thing for sure. And that will optimize how much ventilation is happening, where it's less, you know, energy consuming, not over ventilated, based on additional data sets. So it's a smarter way of doing it. And that's typically a BACnet type. You know, you take the sensor data, you integrate with a BACnet gateway, which we also have, that we can then integrate physically, you know, on site to enhance how BMS operate.
All right, two things. One is, you started this not that long ago, so you kind of jumped from the IoT world into the building world. And it seems to me in our few conversations, you've picked up really quickly on a lot of the HVAC terminology and how they work, and, you know, what ventilation is and how many air changes per hour and ASHRAE and all that. I'm wondering, for those of in our audience that, you know, are in the indoor air quality space, but they're maybe not that familiar with HVAC systems, how did you pick up on that so quick? Was there any particular source or tips that you could give people for how to learn this stuff?
Yes, it's really getting data from people on the ground in the field that deal with real-time real-world issues in buildings. That's really how we came up to speed. We got ideas on what to incorporate in terms of real-time data, sensor data, features into our platform. It was really our customers, talking to the customers, going in the building, meeting with the engineers in the building and asking them, what real-time data would you wish to get so that your life is easier? And, you know, how do you operate your HVAC system? What could we give you? And things like that. That's really how the learning curve accelerated for me personally, for the business as well, coming from the healthcare space. And I always remember this one time I, you know, met early stages, early customer, met with them in their building. I started asking, hey, we're wanting energy data. What else would you want in real time? And they said, come with me. And they took me, ended up in the roof of the building in my high heels. And they wanted to show me their cooling towers in the rooftop, and showed me, here is the data that we want. It's the cooling tower data, and this is why we want it. And I'm there in the rooftop taking notes and learning about, you know, what's important for them. So that was always a funny story, and it's definitely one event that really helped me understand how HVAC systems work.
And what kind of surprised you about schools and their systems? I mean, is it the variety of systems? Is it the maintenance on the systems? What kind of, as an outsider, surprised you going in?
That just most people are blind to what's happening in schools in terms of data that will help them answer whether, you know, they're doing a good job with maintaining, you know, a good level of health and wellness for the students, teachers, everyone, the staff. And so that's the biggest thing, is just that, you know, we're dealing with a big invisible kind of threat put solutions that you can't see if they're working or not. So it's a lot of invisible and blind spots that schools had. So that was a big thing. And then, we've heard a lot of research around the fact that over half of the school buildings in the nation have aging HVAC infrastructure. And even post-COVID, I think it was like just 40% that even made improvements to that. So the aging infrastructure is another issue, which brings IoT, which is a technology that can just be installed in a retrofit capacity and retrofittable way, becomes really important, because it's hard for schools to just rip out all systems and add new ones. And
Sure.
do you actually need to do that? Well, if you actually have sensor data that tells you, well, this school is good, but this school really needs it, then you're able to invest the money in the right way. So it was kind of another thing. And then there were schools, which was interesting, that did, ASHRAE, for example, other organizations were provided recommendations to improve indoor air quality in schools. But some schools, and the big recommendations to bring more outside air, right? Fresh air, better diluted. But some schools don't even have the capability to bring outside air. They're just not designed to do that. So there was just so many of these things that we've seen, and we just think that there's breakthrough in sensor technology and IT technology to bring real-time data. It's affordable, and this is a very, very easy way to start to improve this infrastructure.
And this is something that we didn't have, 10 years ago? You couldn't have done what you're doing now, I'm guessing.
Yeah, sensor technologies become more advanced, and also from an accuracy perspective, from affordability. So we're definitely in a better place nowadays.
I get people that are looking to purchase sensors, maybe just for their home or for small projects. Can you give us any tips on how to find the best sensors? Or if you find the best, just tell us. I don't care. Give us the company name. I mean, I'm here to get good information to our audience. And if you can help point them in the direction of the best types of sensors to use for this type of work, that would be great information.
Yeah, I mean, I think it's more about the type of data. So it's, when it comes to indoor air quality, you want to monitoring, you want to at least have a solution that has temperature and humidity sensing, CO2 sensing, particulate matter sensing. It would be nice to have a VOC sensor. So that's kind of the basis. So looking at solutions that do that. You want to also look at looking at the accuracy of the sensor data, the manufacturer of the data of the sensor technology, making sure that there's no compromises on those sensor data and sensor technology that's used. And then I want to say that one of the things is also looking at, back to the energy side of things, you want to look at solutions that hopefully can have a future-proof path where you're able to add other types of sensors. We're seeing ozone, for example, is a big deal. I heard that I was talking to a former California state senator, and he was telling me there's an area in California where there are more cows than people. And so ammonia levels becomes really important to monitor in those places. And so the future path of adding other air quality sensor, but not outside of these basic ones, is another thing to look at in sensor manufacturers.
Are there any companies you can say have done a really good job of putting together a like small residential or small commercial building sensor that you feel pretty comfortable? Like, I know we've looked at the spec and we've looked at there's been a few, but I'm wondering if there's any in particular that you recommend.
I think that what we have on the Senseware side of things for indoor air quality is something definitely to look at. Particle Plus, which is one of your sponsors, they have really powerful particulate matter sensor. So we like them. We integrated their solution also in some places where we wanted really accurate submicron counting of particle levels. Yeah, I would say that's, the other type, maybe one example.
Okay. Now I've got another text question here. Is there any predictive analysis built into Senseware, like system review of trends, etc.?
Yes, that's a great question. It's definitely the next big thing that we are working on. We currently, since inception, we've gathered so much real-time data. We process over 300 million data samples every day that is coming from these different sensors. And so we accumulated all this data over years and seasons and types of sensors and buildings. And the next thing that we're seeing the indices moving towards is, can you tell us about issues that happen before they happen, and also what are anomalies?
One of the things I've been wanting to ask you, I'm going to read a section here from, I think either one of your people sent me or I saw on the web. Senseware's technology is the first of its kind sensor-based platform supported by 43 patents. It provides real-time assurance into critical areas such as indoor air quality, energy consumption, risk of water leaks, equipment status, and more. Risk of water leaks caught my attention. How do you handle that? Is that a sensor that you put on? Tell me, how do you do that?
Yeah, the water is a big thing in buildings, and typically you don't know how important it is until after there is an issue like a water leak and the damages and the losses that are associated with water. In fact, one of our customers, a construction company, suffered a $2 million water damage loss on their job site. And that's the type of issues that happens when there is a water issue. So as far as adding real-time data, visibility in operating buildings, water is a big aspect of types of real-time data. And, there are different ways to do it. There's connecting to the water meter and looking at spikes and saying, in where you shouldn't see spikes and saying, okay, this is an indication of leak. Monitoring some water pipes, so putting sensors that wrap around the pipe, ultrasonic sensors, and that would look at flow and also detect anomalies in that, and that's an indicator for water leak. And another solution would be just like a water kind of pod sensors that you put locally where there are vulnerable areas, like next to in the mechanical rooms or, places like that in the building, some restrooms and whatnot. So there are different kind of strategies in terms of detecting water leak in buildings. And those are some of the things that we're doing. And we were able to kind of integrate this new type of data set very quickly into our platform.
I've got a comment here from the audience I want you to comment on. It says, so what type of air quality sensor data is most related to indoor air quality? 20 experts may produce conflicting recommendations. I know you're not an indoor air quality expert, but I'm wondering, I know you have used indoor air quality experts to help you develop this program. Mm-hmm. From those conversations, what's most important?
Carbon dioxide, particulate matter, VOC levels, temperature and humidity mostly is the 4-5 big types of sensors that you can relate to indoor air quality in buildings. So, carbon dioxide can be tied to ventilation performance. And then on the particulate matter side, one of the things that we are changing in the way we are monitoring that is to use sensors that we upgraded to sensors that next generation that can measure submicron size particles. And that's important nowadays, we believe, because it's proven especially valuable to assess the performance of the upgrades in air filtration systems that use MERV 13 or 15 filters. And just using those types of more advanced sensor, particulate matter sensors, you could tell whether those filtration systems and improvements are working as they should. So in our world, we're kind of shifting towards, those types of particulate matter sensors as, kind of the minimum that we try to deploy.
I'm kind of reading Ed Light's mind here. Although he also texted earlier about VOCs and monitoring VOCs, that there's no really good data to show that they are correlated with the health effects. How do you handle that? I mean, why VOCs? Is it something that states may mandate, or is it something that you picked up from your experts?
Picked up from experts just as another type of contaminant. And the regular units that we have in solution has the total volatile organic compound type sensor. Doesn't identify specific organic compounds, but it's a good way to just say, okay, an organic compound exists. And it's less of looking at it as a way to say, oh, it's good or not. It's a way for us to say, okay, if we look at it as another contaminant to determine whether the ventilation systems work. So it's an input into our ventilation performance index, because we look at the spikes in VOC and the rate of decay, in addition to particulate matter and CO2. And these three, using three contaminant levels in that type of analysis is really helpful to make sure that we're rating the systems in the right way. So that's how we use it. But we do have in some cases, some buildings want to, for example, go for Fitwel certification. And Fitwel recommends you specifically monitor for formaldehyde as a type of VOC. And so in some cases, we actually add specific sensors that pick up on specific VOCs and deploy those. So it's a case by case. So that's how we approach VOCs typically.
The formaldehyde sensors, the newer versions, how are they economical?
They're definitely more expensive, but there are really good ones that are affordable for sure.
Okay. And I'm wondering, early on, or even all through my career dealing with schools and IAQ and buildings and IAQ, there seemed to be this kind of, I don't want to say adversarial, but maybe they looked at each other a little askew. Like I had the energy guys, and then I had the facilities maintenance guys, and the energy guys were focused on energy and really not that interested in IAQ. And the facilities maintenance guys seemed to be more interested in, making sure the IAQ complaints were brought down. Did you find the same thing when you came into the industry?
100%. You have the sustainability group, you have the IT group in the building, and then you have the engineering group.
I forgot that group. Okay.
Then you want to bring them all together. And, the way we approach it is that we're always saying, okay, well, if you get real-time data around IAQ, around energy and HVAC, you're able to tie the maintenance team, IAQ team, or healthy building team, and the energy people, into a single team. Because now you're not improving on one side and affecting the other. And you're lessening that push-pull and ensuring collaboration. And, just data always provides us objective basis of tackling complex problems like this in buildings. And that's what, we're hoping to kind of influence the industry to move towards, so that, we're not seeing what you have experienced.
All right, John, let's go to the Roundup. The Roundup is brought to you by April Air, providing healthy humidity, ventilation, and air purity solutions for new and existing homes. April Air, healthy air, healthy home at aprilaire.com. All right, I've got two questions. One is, you mentioned when we were talking, at least, the ASHRAE IAQ procedure becoming more important. Now, you're kind of new to this, and yet you're telling me that this ASHRAE IAQ procedure, which has been little used in the past, is very important, or is becoming more important. And we're going to be doing a show in December with the folks from 62.1. So I'm curious, what's been your outsider's perspective on that?
Yeah, the main thing where we started to see an interest in indoor air quality monitoring was as a result of just the industry, the operators looking at some of the ASHRAE recommendations to improve indoor air quality, and just not knowing how to really implement those recommendations. It's been really, in some cases, hard to implement them. And so, ASHRAE had this, as a result of some of those pressures, they had improved on the indoor air quality procedures, IAQP. And in the IAQP, it's basically what it's trying to do is provide some recommendations that you, instead of saying, oh, just bring more outside air, that sometimes is hard to do, it's saying objectively look at the IAQ levels, CO2 levels, for example, and then objectively based on the sense and the data around that, bring the necessary type of or levels of outside air. So this is what it's trying to do, is just address some of the concerns about overventilation, which can increase energy costs. And also bringing outside air means then some of the pollutants from outside can come into the space. So then you have to deal with that issue as well. So this is a new kind of change that, that is becoming more realistic, achievable by operators, is looking at the data objectively to determine how they can configure their HVAC systems. And we're helping with the census data to do that.
And that, ties closely with the discussion we had with Marwa Zatari, Christian Weeks, and Eric Malmstrom. And they're in that business of trying to improve indoor air quality without the added costs of more and more ventilation.
Yes, Marwa is the expert on that side of things. And I think it's what, the direction that the industry is taking with using data plus, changes to HVAC configuration is, I think, going to be more meaningful and effective.
All right, one more before we go, maybe two, but this one, depending on your answer, will definitely be an important one. Where are you headed? What's the future? What do you see down the road 5-10 years from now that we'll be able to do that we can't do now?
I think it's, just in the same way we know everything in real time. I can look at my phone, see where my kids are in real time. The industry is starting to be conditioned to know important things in real time. And so I think the future is gonna look like you go into a building, you open up your phone, you know where you're going, the building status and health, the energy consumption, the air quality in the space. And there's just so much more real-time visibility around the things that matter to us, that it will become just a standard in the industry. So I project that happening, and hopefully we'll play a role in making that happen.
And before we go, is there anything I missed that you'd like to add? I've got 5 other questions I'd like to ask you, but I know you've got to run.
No, I think, as far as summarizing, it's hard to manage what you don't measure. If you're starting to measure, make sure that the data is reliable. So IQ, especially, those types of sense data, make sure it's, that you're vetting those technologies and sensors, and then look at IAQ and energy together, because that's really important to tie those 2 data points. So I think that's my main summary, I guess, of the discussion today.
And I'm just curious, how's business?
Business is great. It is booming, and we're excited. I love our work with schools. I'm a mom, and one of the things we're doing with schools, not just offering the IQ sensor and mounting, we develop a curriculum for the kids to interact with the technology and understand what it means and how things change and what the change means, and whatnot. So I'm very passionate, and that's creating a lot of good opportunities for the business for sure.
Well, that's wonderful. That's something we'll have to talk to you about in the future. It's something that we brought up several times on the show that, until we start teaching our kids
yes,
what's important with respect to their air, this won't really go very far. But I think once people demand it organically, that you're going to see great changes.
100% agreed.
All right. Serene Al-Momen. Thank you, Dr. Al-Momen. Much appreciated. We really enjoyed having you. I'm sorry we had a couple glitches, but we seem to have gotten it all ironed out now. And
it was a pleasure talking to you, Joe. It was so much fun. Thank you for having me. Appreciate it.
My pleasure. We'll get you back sometime. All right. Our thanks to Serene and Senseware CEO, of course. John, you got to have faith. Had his work cut out for him today, but he held us in there real nicely. Our fantastic sponsors, our loyal audience. Next week, we've got Allison Bales on his new book, Buildings Have to Breathe, or Does It? We'll be back next Friday at noon for the next episode of IAQ Radio Plus.
For IAQ Radio, I'm Spike Reel saying thanks for listening.